40.
So we have our last lesson today. 812 washer method revolving around the other axis. Don't forget, for the washer method, our formula is pi times the integral from A to B. Sorry if I'm talking too loud for you to hear your conversations. It's a bad habit of me being a teacher and all. All right. So, pi times the integral from A to B of capital R of x being our outer radius squared minus lowercase rx being our inner radius squared. All right. The challenge here is the same as with the disk method, is when we're not rotating around axis, our radius is going to change. And if you remember the shortcut, if your radius, if we're dealing with rotating around a horizontal line, if your line of rotation is above your function, it's going to be that line minus the function. If it's below the function, it's the function minus the line. Okay? If it's left and right, same concept, but left and right. So if you're to the right of the function, it's going to be the line minus the function. If it's to the left of the function, it's the function minus the line. It's really as simple as I can make it out. Okay. There are other ways to do that. You can think about shifting the graph. Okay. Remember how to shift up and down? Basically, you just add or subtract 1, and you would do that to your radius. And really, wouldn't do it to your radius. You would just do it to the function. All right, if I shifted down 1, then I would subtract 1 from my function. Doesn't make a difference if I square x minus 1 or if I square 1 minus x. Is x minus 1 squared equal to 1 minus x squared? Because what can you factor out of here? A negative 1. A negative 1 squared becomes what? 1. So yeah, they are equivalent. That's why if you look at the answer key and you see that they write theirs backwards, it's because the person who made the answer key did the shifting method. He likes to shift it. Okay. I just prefer to say, well, if it's above the line, then I'm going to do the line minus my function. It's so much easier for me to think visually like that. But it's up to you how you want to do that. There are more than one way. I'm probably going to stick to the way I like to do it. Okay. Because I think it's easier. So, looking at my first question here, find the volume if the region is closed by y equals square root of x and y equals x squared. We're rotating around the line y equals 2. Now, again, we are rotating around a horizontal line. If we're rotating horizontally, what term or what variable must the functions be in terms of? X. Well, if I'm rotating around a horizontal line, it must be in terms of x. Rotating around a vertical line, it must be in terms of y. Right? Again, horizontal line is the same as the x-axis. X-axis horizontal. If it's parallel to the x-axis, it needs to be in terms of x. If it's parallel to the y-axis, it needs to be in terms of y. So that means that I'm going to mirror this function up here, this right here, and I'm going to rotate this and see here. As best as I'm going to do that. So this is going to be rotated around, creating some really nice shape here. Okay. Now, like I said, the way I like to do this is I'm going to take which function is furthest from my line of rotation? X squared. So that's going to be my outer radius. Okay. The outer radius uses the function furthest from the line of rotation. Right, so here R is our R of x, capital R of x. Since I'm rotating around 2, it's 2 minus my function, x squared. Yes?
Could you use the visualizer thing you did one time to show what this would look like? I'll see not.
That's fine. Let's see if I can find it again. Let's save it. Then we'll go here.
And so it would be like. I think it would be like one of the goals that like. Yeah. That's.
I'm in the wrong.
I do. It's not what I'm talking about. The same way.
Apple Studio.
Guys, I'm gonna live. He's with this. I want to spend. It's not really good. That's really good.
Oh, works. So. So.
I'm supposed to start. Okay.
It's 2 x squared. And what was the other one? Square root of x. Okay. 0 to 1. Maybe. Oh. Okay. Something's moving there. It's not quite working the way I won't need it to.
Yeah, there is around. No, so rotate around white is.
Yeah, it's rotated around y equals. Oh, it changed it. For some reason, it changed it to 0. So let's see. No, apparently I can't because this does not work.
I'll make sense.
I don't know if I have to do. No, this should be fine.
This one. Well, not like you picture the shape, it's like, how do you say, oh, we first got pictures.
Where?
But I mean, up from the left, it looks like it's still is the original. Yeah, the press that refresh.
Ah, it is. Yeah. Okay, that's good catch. You can see it. So yeah. So there's my function.
Which one made them power project? Yeah, but it's not exactly the power thing, it's just the.
That is not our equation, but yeah, that's the same concept.
Just like my.
Oh, it changed it all back to what it was. Okay. Nah. Yeah.
That's good enough.
Yeah. But anyway, again, if you want to keep it as simple as possible, since my line of rotation is above my function, my larger radius will be my line of rotation minus the function furthest from it. The smaller radius will be the line of rotation minus square root of x.
And then because it's the line is above it.
Yeah. If it was below, it would be the function minus the line. All right. So that gives me the pi times the integral from 0 to 1 of 2 minus x squared minus 2 minus square root of x squared dx. Now, that's one way to do it. Okay? If you are a fan of shifting functions, okay, what if we shifted everything down to where my line of rotation was the x-axis? Okay? If we shifted everything down to where my line of rotation was the x-axis, what would happen to all my functions? They go down by 2, right? So that means if everything shifted down by 2, my first function will be y is equal to x squared minus 2, right? And my other function will be y equals the square root of x minus 2. All right. In those cases, we would have pi times the integral from 0 to 1. What function is furthest from the x-axis? In that case, no, it would still have to be, because I shifted it down to the function furthest from the x-axis would still be the 2, x squared minus 2. So that would be x squared minus 2 squared minus square root of x minus 2 squared. Like we said, is if I square 2 minus x squared, is that equivalent to x squared minus 2 squared? Are they the same thing? Yeah. So that's why, again, when you look at the answer key, the person who does the answer key likes to shift. So they're going to write it as x squared minus 2 or the function minus 2. I just prefer to keep it as simple as possible. Okay, and just if it's above, it's the line minus the function. If it's below, it's the function minus the line. I feel that that's the easiest way to do it. So I'm going to stick to doing it that way. So if you want to shift, you can do that. Once you shift, you're back to not having to worry about where the line of rotation is. It's the x-axis. Yeah. All right. Just show you both will give you the same answer. Let's clear this. So we have second pi. Second pi. There we go. So times the integral from 0 to 1 of x squared minus 2 squared minus second square root of x minus 2 squared. So that's what we get if we did it the shifting method. All right. So second pi times the integral from 0 to 1 of 2 minus x squared squared z squared minus 2 minus the square root of x squared. So yeah, same answer. We'll make a difference in the world. So there's my volume 3.246. So this other one, we were rotating around line x equals -1, so we're rotating around this line right here. So this time the function needs to be in terms of y, or so in terms of y. So we'll solve for y. So y equals x squared plus 1, y minus 1 equals x squared, x equals plus or minus square root of y minus 1. And since we're dealing with the right half of this, it's not going to be the negative. It's just going to be positive. Why did everything shift? All right, for the other equation, y equals 2x plus 1. We have y minus 1 equals 2x. So x equals 1/2 y minus 1/2. All right. So now, since my functions are to the right, whatever is furthest right is what goes first. So the furthest function from my line of rotation is the square root of y minus 1. So my larger radius is going to be the square root of y minus 1 minus a -1. That's my line of rotation. So we can go ahead and change that to +1. My smaller radius will be 1/2 y minus 1/2 minus a -1. Again, we can change that to plus, and we can even simplify that to be positive 1/2. So pi times the integral from 0 to, not 0, because this is in terms of y, from 1 to 5 of square root of y minus 1 plus 1 squared minus 1/2 y plus 1/2 squared dy. So, second pi times the integral from 1 to 5 squared x plus 1 plus 1 squared minus plus 0.5 squared. 16.755. And that is it for the notes. So this lesson will have you review several topics from Unit 8. So be careful because not all the homework will just be this one thing we just covered. It will be a bit of a review. All right. The big thing is you want to be able to distinguish which strategy you want to use to solve these. Okay. So it's not just going to be 8-12 homework. It's basically a review of Unit 8. Okay. So know when to use washer method, when to use this method. Okay. All strategies though. All right. So tomorrow, AP multiple choice questions. Thursday, AP pre-response questions. We'll do them together. And then I'll give you guys a review on Friday. We'll go to review Monday and Wednesday. We have no school next Tuesday because of the election. Local elections. Yeah. They have to close the schools because they use schools for the election polls. So yeah. I have to go to work. But so. Anyway, test next Thursday. I talked to Miss Johnson down in the conference. She said there is something that we can do to give us a little bit of practice for the AP on how to use the computers and what it's going to look like to give you guys a little more comfortable in using online AP tests. Okay. Yeah. If you're not taking the AP tests, we do have a final. If you're getting UMSL credit, you have to take the final.
What?
If you're getting UMSL credit, you have to take the final.
Huh.
But if you have an exemption for the final, you can exempt it and it will not count for your high school grade. Your high school grade will be whatever your grade is, so that's fine. It will only affect your UMSL grade because those don't have to be the same. Yeah.
So you can exempt it for high school, but you still have to take it.
Yeah. Because your UMSL grade will basically be semester 1, semester 2, and then final exam is 20%. So that'll be
Our high school grade is actually our.
if you take the final, yeah, and you don't skip the final, yeah, you're sort of okay. Because we didn't do a semester exam, your final exam counts for more, and your final exam will be cumulative over the whole year. So back to limits, derivatives, all the fun, easy stuff we did first semester.
Fun?
Yeah. I mean, comparatively speaking, it was easier than this, right? Actually, this wasn't too bad. The more I do this, the easier this gets to be. It's the stuff I'm doing in BC. We did